With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, if the capacitors are uncharged prior to switch being closed, now the amount of heat dissipated in the resistors R1 and R2 after the switch is closed would be in the ratio of. So let's see the solution here. Okay. So in this question you can see that we have given here a circuit in it consisting of two capacitors C1, C2, R1, R2 and one EMF battery E. Okay. Now when switch S, let's suppose when switch S will be closed. So in that case, this circuit will be get divided into two individual circuits. That is, let's suppose this will become the first circuit and this will become the second circuit. Now in the first circuit, it will consist the capacitor C1 and resistor R1 with battery supply of E, and in second circuit we will have the capacitor C2, resistance R2 and the EMF E. Okay. Now as per the question, we have to find the ratio of amount of heat dissipated in the resistor R1 and R2. So for that, first of all, we need to find the amount of heat dissipated in the resistor. Okay. So when we connect the switch in, so obviously as initially the capacitor is uncharged, so just because of closing the switch, because of this EMF E, the capacitor will try to charge. Okay. And hence again just because of this resistors R1, this will try to discharge throughout this resistor, and just because of this heat will be dissipated into the resistor, and that heat dissipated is given by the formula H is equals to UI minus UF plus ES minus E naught. Now you would say, what are these terms? So UI is nothing but the initial energy is stored in the capacitor. UF is the final energy stored in the capacitor. ES is the energy supplied by the EMF. And E naught is the energy dissipated by the cell. Right? Okay. So from here, for the first circuit, we can say that the heat dissipated by the resistance R1 will be given by H1 is equals to UI minus UF plus ES minus E naught. So this will become, now as initially the capacitor is uncharged, so there will be no energy stored in the capacitor, that's why it will be 0 minus, now final energy of the capacitor will be equals to, that is 1/2 of C1 into E square plus ES minus E0, this will become C1 E square. So simply after subtracting this, we get H1 will be equals to 1/2 of C1 into E square. Okay, let's suppose this as equation number 1. Now similarly, if we talk about the second circuit, okay, so we can say that the heat dissipated by the resistance R2 will be given by H2 is equals to initial energy. Now as initially uncharged capacitors, that's why its initial energy will be 0 minus final energy will be 1/2 of C2 into EMF square, that is E square plus ES minus E0 will be nothing but here as C2 into E square. Okay, C2 into E square. So from here what we get, that is H2 will be equals to 1/2 of C2 into E square. Okay, let's suppose this as equation number 2. Now as we have to find the ratio of this, so from here the ratio of heat dissipated in resistance R1 by R2 will become equals to, that is H1 by H2, this will be equals to 1/2 of C1 E square divided by 1/2 of C2 E square. So from here this 1/2 E square will be cancelled out, and we simply get this ratio to be equals to C1 by C2, and this is nothing but our required answer. Now according to option B will become correct answer for this question. So this is the required solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.